So logarithms are, to start with anyway, just a nice alternative notation to something that we're used to. So consider this. We all know that 2 cubed is 8. Well, we can write this in logarithmic notation as followed. This is an equivalent expression to this one. Log base 2 8 equals 3. So these two things are completely equivalent to each other. And what I would do is, if I want to think about what this log expression really means, think of it like this. I'm reading it left to right. What is it I raise 2 by to get 8? Well, that's 3. And if you keep saying these logarithms like this, then we are going to get this right. What is it I raise that smaller number by to get the larger number? I raise it to the power of, and that's our number on the right. So if we understand that, we can pretty much get started. There's one more thing to say, is that if we have a logarithm and there is no base, just like this, then really we're assuming there is a base of 10. Okay, the standard way of writing logarithms, at least back before calculators, was with a base of 10. So if you don't see the base there, you just assume it is 10. All right, so with that said, let's see if we can work with that to work out some expressions. Take a look at these. Pause the video if you like and have a go at this yourself. So in part A, log of 100. Well, as I've just said, if we have a logarithm with no base, we need to assume base 10. So we could rewrite this with that in so you could see it. And again, say that same expression to yourself. What is it I raise 10 by to get 100? Well, of course, 10 squared is 100. So the answer is 2. Right. In part B, let's think about this. What is it I raise 10 by again to get the 4th root of 10? Well, the 4th root of 10, it really could be changed into the power of a quarter, right? That can be swapped around like that. So in this one, well, to be honest with you, the answer is staring at us in the face. What is it I raise 10 by to get 10 to the power of a quarter? Well, literally a quarter, isn't it? Obviously, it's going to be 1/4. And that's it. We're done. Let's see if we can have a go at a few of these. Now, I won't perhaps do all of these, but let's just talk through them maybe. We'll start with those easy ones. So if we look along the top line, what is I raise 10 by to get 10,000? Well, of course, it's 10 to the power of 4, right? So our answer is 4. As we've seen, let's have a look perhaps at f. So log of a cube root of 10. Well, a cube root is a power of 1/3. So, of course, it's telling us straight away it's a power of 1/3. But for some of these, we might need to do a little more work. So let's take a quick look at perhaps j. So we have got log, and I'll write the base 10 in there so we understand, 100 over the root of 10. Now, for a question like this, we want to try and write the number inside the logarithm in those brackets as a power of 10. So we could do that because this is equivalent to 10 squared over 10 to the power of 1/2, right? Square root of 10 is the power of 1/2, 100 is 10 squared. And using our laws of exponentials, we could bring that together as a single power of 10. Log base 10, 10, well, I would do a subtraction, wouldn't I? 2 take away 1/2 is 3/2. So what is it I raise 10 by to get 10 to the power of 3/2? 3/2. That's pretty much it. Perhaps we could do one more. Let's have a look at the last one, L. In this one, we've got log base 10, and it is 1,000 root 10. Okay, so let's write both of those as powers of 10. We've got log base 10 of 10 cubed times 10 to the 1/2. So I could combine those quite easily and write those as log, excuse me, I'll keep consistent with my notation, log base 10 of 10 to the, well, 3 is like 6/2. I guess if we add that 1/2, we would have 7 over 2, just like that. So if we work that out, what is it I raised 10 by to get 10 to the power of 7 over 2? It would just be 7 over 2. Okay, let's do some more. Right, so let's have a quick look at this. Write an equivalent exponential statement for log base 10 of 1,000 equals 3. Okay, well, what we're asking for here is kind of the backwards version. So we've got log base 10 of 1,000, equals 3. So I'm saying, well, what is it I raised 10 by to get 1,000? 3. So that's going to be 10 cubed equals 1,000. Okay, and in part B, let's go the other way. So we've got 3 to the power of 4 equals 81. So I'm going to write, what is it I raise 3 by to get 81? I raise it to the power of 4. Again, that phrase is so powerful when you're doing these ones. Right, now then, let's move away from base 10 and have a little think now about some other bases. So let's see if we can evaluate these. So A, what is it I raised 2 by to get 16? Okay, that should be pretty straightforward. It's going to be 4. And again, I could do this the long way around. I could write this as log base 2 and write my 16 as 2 to the power of 4. And then we can just drop the 2. And yeah, what is it I raised 2 by to get 2 to the power of 4? Well, 4, of course. So part B, well, we've got a base power of 5, so it's going to be useful to write my 0.2 as a power of 5. So log base 5, well, 0.2 is a fifth, which is 5 to the minus 1. So it's just going to be minus 1. Okay, so in part C, we've got that 100, and it's the fifth root of 100. Let's try and write that with a 10. So we'll start off by saying log 10, and we'll have 10 squared. That's my 100, and we've got a fifth root. Well, that's to the 1 over 5. So combining those by multiplying, we'll have log base 10 of 10 to the 2/5. And now we can just reel off that is just 2/5. D, well, again, let's try and write this as a power of 2. We'll have D is going to be log base 2. So we've got 2 to the half, but it's 1 over, so we've got it negative. So this is just going to be negative a half. Okay. Now then, again, we won't do all of these questions, all right? Pause the video, have a go. Is there any that don't make sense to you? Maybe we should just pick a couple, or maybe just one. The last one looks particularly nasty. Should we just have a quick look at X here, look? Right, so we've got log base 4. We've got to try and write this as a 4 to the power of something, I guess, right? So how could we do that? Well, first of all, we could say it's 1 over, let's do some work here. So 2 is the square root of 4. So we could write that 2 there like that. Now the square root of 2 is, again, the square root of 4, which is 2, square rooted, yeah? So we could at least start by thinking of it like that. Let's carry on with this, try and combine this now. Now, we'll leave the 1 at the top just for a moment, perhaps. Let's bring this together. So we'll have 4 to the half multiplied by 4 to the quarter. And we can bring those together by addition. So we will have, well, 4 to the half is like 2 quarters. Plus that extra quarter is 4 to the 3 quarters. So bringing it together, now that 1 at the top, that makes this a negative exponent. So we're going to have 4 to the minus 3 quarters. And so therefore our answer is just going to be minus 3 quarters. Okay. Now, if we have an x or a variable there as a base, it makes no difference. But the technique here is exactly the same. Let's just take a quick look at f and see if we can do that. So we will rewrite this as log base x, x to the 1 multiplied by x to the half. Well, that's going to be log base x, x to the 3 over 2. And so again, our answer is 3 over 2. No different to any other question.